Alright, let's look at the homework 7.7, problem number 5. Alright, so we want to find T4 and M4 for this given integral. Alright, so let's do that. Alright, so I'm going to call this integrand right here f of x. Alright, so let's find T4. First, we have to find delta x. Alright, delta x is going to be always b minus a over n, right? So b is, upper limit, so it's 2, right? Minus a is the lower limit of the integration, so it's 1. And n is 4, right? So we have 4 here. So we know that delta x is going to be 1/4, right? Then we can just go through the formula. So trapezoid rule, T sub 4 is going to be, right, delta x, so it's a 1/4, right, divided by 2. That's part of the trapezoid rule formula, right? Then you do f of, right, so we look at the interval from 1 to 2. So you have a 1 to 2. Right, we split that into 4 because n equals 4, right? So it looks like this is going to be 1.25, and this is 1.5, so 1.75, right? So the first one is 1, so f of 1, right? Then it's going to be 2 times f of 1.25 plus 2 times f of 1.5 plus 2 times f of 1.75, and the last one is f of 2. So we just need to compute that. So let's get this value using Geogebra. Alright, so we first define f of x. Alright, our f of x is 17 e to the 1 over x. Alright, put that in there. Alright, so we have that. Then what we have to do is, let's see, 1/4 over 2 is just a 1/8. So I put 1/8 here. Alright, then we just have to put f of 1 plus 2 times f of 1.25 plus 2 times f of 1.5 plus 2 times f of 1.75 plus f of 2, right? Then hit enter, right? So it came out to be 34.54. We need 6 decimal places, so we go to option. Let's see, go to option, rounding, and I guess I have to do 10 decimal places, right? So you have 34.5542179, right? So let's put that in. Alright, so we got 34.542179. Alright, so let's double check. Submit for testing. Alright, it came back and we got this one correctly. Alright, so let's do the midpoint rule as well. Alright, so midpoint rule. And midpoint rule M sub 4. m sub 4. Right, so delta x is the same, so 1/4, right? Then what you do is we have to use the midpoint of each one. So here, let's see, so it's a 1 and this is a 1/8. So this is going to be, maybe I'll use a fraction here. So let's see, 9/8. And here it's going to be 11/8. And here it's going to be 13/8. And here it's going to be 15/8. Right? So those are the midpoint. So we plug in those into a f function. So first one is f of 9/8 plus f of 11/8 plus f of 13/8 plus f of 15/8. Right, so let's compute that and bring out the GeoGebra. Right, so we have 1/4, and then you have f of 9/8 plus f of 11/8 plus f of 13/8 plus f of 15/8. Right, hit enter. Right, so it came out to be 34.241517-ish. Right, so let's type that in. Alright, so what we got was 34.241517. Right, so let's check the answer. Submit for testing. Alright, I came back and we got this one correctly. So we're done with part A. Alright, so let's do part B. So finding the error bounds for trapezoid rules and midpoint rule. Alright, so here's the error bound formula, and don't worry if you don't remember then, I'll provide these formulas. And in order to find k, we have to find the second derivative. So remember that for this problem, f of x was 17 times e to the 1 over x. Right? So let's take the first derivative. F prime of x is going to be, right, so I'll leave 17 alone. Right? Derivative of e to the 1 over x is e to the 1 over x times derivative of 1 over x is negative 1 over x squared. So I'm going to put the negative sign here and x to the negative 2 power. Right? So we have that. Right? Then we have to take another derivative. So let's take 1 f double prime of x. Right? So I'm going to probably put negative 17 outside. Then take the derivative of the rest. Right, derivative of x to the negative 2 power would be negative 2 times x to the negative 3 times the second guy, e to the 1 over x. Right, plus x to the negative 2 power times derivative of e to the 1 over x is negative. Let's see, what was it? X to the negative 2 e to the 1 over x. Right? So we have that. Right? So this is going to be equal to, let's just try to simplify. So you have a negative 17 is outside, so that's that. And actually there's a negative sign there, so I'll take this negative sign and negative sign there and then combine with that to turn it into a positive sign. right? Then we took care of 17, and e to the 1 over x is in common, so here and here. So we have e to the 1 over x is in common, right? Then we can just do here, right? You have a 2 over x cubed here, plus, right? So this is going to be, so I took care of this guy right here. Then combining x to the negative 2 and another x to the negative 2. So it's going to be 1 over x to the 4th power. Alright, so we got that. Alright, so it looks like we know that the k value, so we have to find the absolute upper bound of second derivative. Alright, and so if you look at this guy, and the x is going from, let's see, I have to double check, the original integral is going from 1 to 2, right? So between 1 and 2, this function is actually a decreasing function. As you can see that as x gets larger, this value gets smaller, and same with e to the 1 over x. So in order to get the largest possible value, we plug in the smallest possible value. And x is between 1 and 2, so we plug in 1. Alright, so it's a 17. And then you have a 2 plus 1 e to the 1st power. Alright, so this is going to be 17 times 3. Let's see, 3 times 7 is 21, and 3 times 1, so it's a 51 e. Alright, so we can take this as a k value. Alright, so let's find bound for a trapezoid first. So you have area bound for trapezoid is going to be, right, k value is 51e, then b value is 2, a value is 1, raise it to the 3rd power, and you have a 12, and n, I think we use, let's see, we use 4 for n, so it's going to be a 4 squared, right? So we just have to compute that value, right? So first, 2 minus 1 is 1, cube is 1, so this is going to be 1, so I'll just scratch that out, right? Then we just have to compute, right? So this is going to be equal to 51e, actually, why don't we just punch it into Geogebra here. Alright, let's open up Geogebra. Alright, so let's see, it's a little slow here. Ooh, it's moving. Alright, so I'm going to bring this guy up here. Alright, so let's compute the value. It's 51 times e to the 1, so e, divided by, and 12 divided by 4 squared is 16, so we get that value, right? 0.72243 ish, right? So let's type that in first to make sure. All right, so that value we got was 0.722044, right? So let's check the answer, submit for testing. Alright, it came back. We got the area bound for trapezoid rule. We got that one right. And for midpoint rule, it's pretty much the same. We just have to use a different formula. So area bound for midpoint rule is going to be less than equal to, alright, k is again 51e. And then you have a 2 minus 1 to the 3rd power, same, and a 24 n squared, or actually n is 4 squared. Looks like it's going to be a half of the it looks like it's just a half of the area bound for a trapezoid. So maybe I can just do this, right? Take C divide by 2, right? So that's going to be 0.361022, right? So let's type that in. All right, so we got the 0.361022, right? And then check the answer. All right, I came back and we got area bound for midpoint rule correctly. All right, so let's do part C, and we just have to find the n value to guarantee the accuracy within 0.0001. All right, so let's do that. All right, so let's look at the area bound for trapezoid rule. So you have E sub t, right, is less than or equal to, right, k, remember that it was a 51e, right, and so this is the same 2 minus 1 cubed, so it's 1 anyway, so I'm not going to write that down. All right, so you have a 12, and n we don't know yet, right? Then we're going to make sure that this is going to be less than or equal to 0.0001, right? And first step, take the reciprocal of both sides. So we have 12n squared over 51e, right? So reciprocal of that is 10,000, so we put the 10,000, right? So this is greater than or equal to. Right, then we can multiply both sides by, we need to get rid of 51e, and we need to get rid of 12. So that we get n squared has to be greater than or equal to. All right, so we have a 51, there's going to be 0, 1, 2, 3, 4 zeros, e, and then divided by 12. Alright, so last step would be, we can just take the square root. So n is going to be greater than or equal to, and square root of 51, and you have 0, 0, 0, 0, e over 12. Alright, so let's compute this value. Alright, so we have Geogebra here. Alright, and then I'm going to compute, let's see, a square root. So square root of, alright, so it's a 510000 times e, hopefully that would work, divide by 12. Alright, so put that in there. Alright, the value is, right, and it came out to be 339.89, so it's a 340, right? So this is going to be 340, right? So let's type that in. So n has to be 340. It's kind of a big value. All right, let's check the answer. Submit for testing. All right, came back. Looks like we got this one correctly. All right, and we do the same thing with the midpoint rule. All right, so midpoint rule. So you have E sub m, and the k value is exactly the same, 51e. B minus a cubed is going to be 1, and you have a 24n squared. Alright, so this is less than or equal to 0.0001. Alright, same steps. Alright, take the reciprocal of both sides. So you have a 24n squared over 51e is greater than or equal to 10,000. Alright, then I'm going to multiply by 51e over 24. Right? So then n squared is greater than or equal to 51,0,0,0,0e over 24. Right? Then we take the square root of both sides to get n is greater than or equal to square root of 51,0,0,0,0e over 24. Right? So let's compute that. Right? So we have a square root of, right, 51,0,0,0,0 times e, and then divide by 24. Right? Came out to be 2688. Right? So let's put that in. 2688. Oops. Alright, let's check the answer. Submit for testing. Alright, actually I computed the number wrong. It was actually 240, so it's a 241. Alright, so let's retype that. And here. Yeah, it's got to be small too. 241. Alright, so let's check the answer. Alright, it came back and looks like we got all of these guys correctly. Alright, that's it. I hope that this was clear.